Okay, so since we now have some idea about the Taylor and then Maclaurin series, let's go ahead and try some example. Okay, so the example I have here is the function f of x equals what? E to the power x. Okay, so let's find the Taylor series, okay, for this function centered at what? A equals what? 2. Okay, so this function is what? Centered at what? 2. Okay, so let's write down the general formula. So the general formula of f of x will be equal to what? So from n equals 0 to what? Infinity. Okay, that will be the n derivative of the function at a over what? N factorial times x minus what? A to the power what? N. Okay, so now in this case, r is given to us to be what? 2. So we can write this as the sum of this starting from 0 to infinity for the n derivative of the function at 2 over what? N factorial times what? X minus what? 2 to the power what? N. So we've been given our A value. Okay, so the main thing we have to focus on is what? Is the coefficient of what? This series. Okay, so the coefficient of what? This series. Okay, and you've been given what? From what? 0 to infinity. So that means that you are starting from what? 0 and then you go on. So my n values will be equal to 0, 1, 2, 3, 4, and then and so on. I'm going to end at 4. Okay, so now what you are going to do next is that you want to focus on the coefficients. Okay, I want to focus on the coefficient. So the general formula for the coefficient Cn equals what? F the n derivative of what? The function at what? A. And in this case our A is what? 2. Okay, over what? N factorial. So this is what you are going to what? Focus on. Okay, so now I'm going to write what the series will be. Okay, so that will be f of x. Okay, that for e to the power x will be what? The zero derivative of the function at 2 over what? 0 factorial. Okay, plus the first derivative of the function at 2 over what? 1 factorial. Okay, multiplying x minus 2 to the power what? 1. Okay, plus the first derivative, the second derivative of the function at 2 over what? 2 factorial. Okay, multiplying x minus 2 to the power what? 2. Okay, so this will go on. So let me write this part down here. So that will be okay. Let me actually try and then shift this a bit. Okay, okay. So plus the third derivative of the function at 2 over what? 3 factorial. Okay, multiplying what? X minus. Let me write this here. X minus what? 2 to the power what? 3. Then this will continue. All right, so this will be our series. Okay, this will be our series. So now we will leave this here, then we come and focus on the coefficient. Okay, so because you know that what we already know this value. So now let's focus on what this ones. That's the coefficient. So we are now going to focus on this value here, this value here, and then so on. Okay, so now let's go ahead. So let me get some space. Okay, that's not this, not this. Okay. Okay, so now let's continue. Okay, so we know our n values to be equal to 0, 1, 2, 3, 4, and then so on. Okay, but I will end at 3. Okay, so I believe you can continue. So you continue and then just practice so that you get used to it. Okay, so now we are focusing on what? We are focusing on the coefficient. Okay, so the general formula is the n derivative of the function at 2 over what? N factorial. Okay, so now the function f of x is given to us to be e to the power what x. So if I want to find the first coefficient, okay, I'm going to find the zero derivative of what the function. Okay, so the first derivative of the function at 2. Okay, the first derivative of the function at 2. So let me actually make this, c sub 0. So c sub 0 is what? The zero derivative of the function at what? At 2. Okay, about 0 factorial. So what will be the zero derivative of what? E to the power x. The zero derivative of e to the power x. Okay, the zero derivative of the function, okay, x will give us the function itself. It's like they are saying that you are taking the zero derivative of it, so it will give you the same function. Okay, so the zero derivative of the function of 2, this will give me e to the power what? 2 over what? 0 factorial, right? Okay, and this will be the same as what? E to the power what? 2. Okay, so that's what you have for what? For the first coefficient. So that's what the zero derivative of the function at 2 over 0 factorial give us what? E to the power 2. So I can write e to the power 2 here. E to the power 2. Okay, so now let's focus on what you have remaining. So this one to be what? Let's say c1 will equal to the first derivative of the function at 2 over what? 1 factorial, right? Okay, so now what will be the first derivative of this function? That's the first derivative of the function x for what? E to the power x. The first derivative of the function e to the power x will give us what? E to the power x. No matter the number of derivatives you found for exponent x, you still get exponent x. Okay, even if you find the third derivative of this exponent x, you still get exponent x. Okay, so now since you know that, the second thing would be what? E to the power 2, right, over what? 1 factorial, which will give us e to the power 2. So this will give me plus e to the power 2, okay, multiplying x minus what? 2 to the power 1. Okay, so now let's go ahead and then do same for the second derivative of the function at 2 over 2 factorial. So which is what? For this. Okay, so let me get some more space here. Okay, so let me clean this. Okay, since we are done with that, let me take them off. Okay, all right, so I have c2 to be equal to what? The second derivative of the function at 2 over what? 2 factorial, right? And the second derivative of this function will give me the same function. So I have what? E to the power 2 over what? 2 factorial. So I can write that in place of what I have here. So that will give me plus e to the power 2 over what? 2 factorial. Okay, let me try and shift this up. Okay, all right, I think you can manage this. Okay, so that will be plus e to the power 2 over 2 factorial, okay, multiplying x minus 2 to the power 2. Okay, so now that's what I have. So I'm going to do same for the what? This one also. Okay, that's the third derivative of the function at 2. Okay, so that would be c3 equals what? The third derivative of the function at what? At 2. Okay, about 3 factorial. This will also give me e to the power 3 over 3 factorial. So I just can write this here. Okay, plus e to the power 3 over 3 factorial. Okay, multiplying x minus what, 2 to the power what, 3. Okay, so this will keep on going. So that will give us what, the Taylor series expansion for it, for the function f of x equals what, e to the power x. Okay, so next we are going to do same for the what, Maclaurin series. Okay, so that we understand. So you are going to find the Maclaurin series expansion for the function f of x equals what, e to the power x. Okay, for the Maclaurin series, it is centered at what, 0. Okay, so we take our a to be equal to what, 0. Okay, so now let's write down the general formula. So f of x will be equal to this general formula from n equals 0 to what, infinity, for the n derivative of the function at 0 over what, n factorial, okay, times what, x minus what, 0 to the power at n. But x minus 0 to the power n will still give us what, x. So I can just write this as times what, x to the power what, n. Okay, so this is what I have now. So this is what I am going to use what, to get what, the series. Okay, so now n will start from 0, 1, 2, 3, 4, and then we'll continue. Okay, so this is what we have now. Okay, so now let's try and then write down the series. Okay, so that it will be easy for us. Okay, so the first one will be the 0 derivative of the function at 0 over what, 0 factorial, okay, plus, okay, let me make it times what, x to the power 0, okay, plus the first derivative of the function at 0 over what, 1 factorial, okay, times what, x times x to the power 1, okay, plus the second derivative of the function at what, 0 over what, 2 factorial times what, x to the power what, 2, okay, plus the third derivative of the function at 0 over what, 3 factorial, okay, times x to the power 3. So this will continue. Okay, so our main focus is was to find what, the coefficient, okay, which will take this to be c1, c2, c3, and then c4. Okay, so I'm going to find what, c1, c2, and then c3, and then also c4. But we know the general formula for this is c sub n equals what, the n derivative of the function. In this case, our center is what, 0, okay, over what, n factorial. Okay, so that's what you are going to apply here. Okay, so now let's continue with this. Okay, so we focus on what, find what, the coefficient. Okay, so the first coefficient, that will be c sub 0. Okay, this will give me the 0 derivative of the function what, at 0 over what, 0 factorial. And the 0 derivative of the function will still give me 0, so that will be e to the power 0 over what, 0 factorial. So let's find the value of this. The exponent of 0, I think, should give me, the exponent of 0 will give me 1. Okay, so I have what, okay, this will be equal to what, 0. Okay, let's make some corrections here. Okay, let's make some corrections here. Okay, so this should actually be c sub 0, c sub 1, c sub 2, c sub what, 3. So now you got our c sub what, our c sub 1 to be the exponent of what, 0 over what, 0 factor, and that give me 1. So I can come and write my 1 here. Okay, so now let's do for c sub 1. Okay, so that will be the first derivative. Okay, of the function at 0 over what 1 factorial. The first derivative of the function will still give what the function. So since it is what exponent, so I still have what e to the power 0 over what 1 factorial. Okay, and this will be equal to what 1. Okay, so I have what plus 1. Okay, and it is multiplied by x here, so I have what plus 1 times what x. So this will give me plus x. Okay, so that's what I have now. So now let's go ahead and then do for the third value, okay, which is c sub 2. Okay, so for c sub 2, I'll take what the second derivative of the function at what 0 over what 2 factorial. Okay, and the second derivative of the function will still give us the function, so we have the function to the power 0 over what 2 factorial, and this will give me 1 over what 2 factorial. So I just come and write down here, so I have what plus 1 over what 2 factorial. Okay, multiplying this x squared here times what x to the power 2. Okay, so now let's do for the third one also. So that's c sub 3. Okay, so I have c sub 3 to be equal to the third derivative of the function at 0 over what 3 factorial, and the third derivative of the function will still give me e to the power x. Okay, so that will give me e to the power 0 over what 3 factorial. So this will be 1 over what 3 factorial. So I'm going to put this in place of what I have here. So I have what plus 1 over what 3 factorial. Okay, 1 over 3 factorial times what x to the power 3. I can continue this as 1 over 4 factorial, okay, times what x to the power 4. Okay, so I believe by now you've seen the trend, so you can also see that 1 over what 5 factorial times what x to the power 5. You see that what that's how it's going to continue. So with this, I think we can find what a general formula for this series. Okay, so let's see what that would be. Okay, so I can define a general formula for this to be equal to 1 over what n factorial, okay, times what x to the power n. Okay, so this will be the general formula for this. Okay, so if I want to find the first term, okay, the first term, that will be what this term here, so that will be what 1 over what 1, the first term starts from what 0, so that will be 1 over what 0 factorial, okay, times what x to the power what 0, and then 1 over 0 factorial give me 1, okay, and then times what x to the power 0 will also be what 1. So at the same time I have what this one that I have here. If I want to apply it to this one also, that's the second term, so I have what 1 over what 1 factorial times what x to the power what 1 times what x to the power what 1. So this will actually give me what x, right? Okay, so let's do it for the third term also. So I have what 1 over what 2 factorial, right? Okay, multiplying x to the power what 2. Okay, so you see that what this formula actually works. So you can write plus for 1 over what 1 over n factorial times what x to the power n. So that be the series. So this will be the Maclaurin series expansion for the function f of x equals what e to the power x.